Today is February 12th. All right. You should know all of these basic shapes. Good. You guys are going to have a test on Friday.
Yes.
Yeah, and it's a good one. You have, there are 37 or 38-minute classes, I think, which is more than enough time to do this. It is a matching test again. Okay, so matching the function, matching the equation with the graph. All right, and I just want to say, when in doubt, use your damn calculator. That's what they're for, okay? So please practice using your calculators. Yeah. You will not be able to use your notes. Is there what? There, we will review tomorrow. No, because you can use your calculator. Okay? So there's absolutely no reason that you shouldn't be able to get 15 out of 20 correct. Why? Because 15 out of 20 of them you can plug directly into your calculator. All right? The last 5 you won't be able to. But 15 out of 20 you can absolutely get 100% on. You don't get any helpers. Okay? Your calculator is help enough. Ladies and gentlemen, what does the absolute value of x look like? A v. Very good. Absolute value v. The square root of x? Swoop. Square root, swoop. Square root, swoop. Cube root. Wave. The breaking wave. You should know these. That is the breaking wave. You got your 3 points on the diagonal there. X squared. Parabola. That's the parabola. And then x cubed. The slide. A wedgie water slide. That really steep slide. Wedgie water slide. That's right. The really, really tall slide. All right. So, again, you should know all of these shapes. Today, we're looking at horizontal stretch. Horizontal stretch or shrink, I like to call stretch or compress. Horizontal stretch or compress is horizontal because it affects the x values. So this is a number that's inside with x, and it's going to cause a horizontal change. So this is going to stretch our functions horizontally or shrink them. Now, because it's with x, everything with x is opposite of what it looks like. Right? If you have y equals the absolute value of x plus 2, what does this do? What does x plus 2 do to the graph? Left 2. It's always opposite. Inverted, changed, different, okay? Everything with x is messed up. Same is true today. So here we go. Pay attention. Got to write all this stuff down. Example 1, graph the core or the parent function, whatever word you want to do, parent function or base graph, the basic shape, I don't know what word, basic graph, then shift, state the domain and range. So whatever core, I don't know, base graph, I don't know what word. I change it every year. I should really find a word that I like. Boring, graph the boring. Plot the boring graph and then shift. Okay. State the domain and range. Oh, once again, I am underprepared. This is what happens when I print the notes off 3 weeks ago and forget to fix them. Oh, well, that's right. I didn't complete them. I forgot to graph my picture. There we go. Okay. We'll do that. Okay. So letter A here. We have y equals the absolute value of 1/2 x plus 1. What is our base graph here? What's our basic shape? A V, that's right. Absolute value of x, that V shape. So that is the graph that I'm going to start with. And a bunch of stuff is happening to it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Give yourself a good graph. And I'm going to start by graphing those 3 main points for my basic shape graph, which is the basic V. And then how many transformations, how many changes do you see with this equation? 2 changes, sure. We have this 1/2 in there, and we have the 1. And when I look at this 1/2, this is 1/2 times x, all right? So we have a product here, multiply, versus addition or subtraction. Which one do you suppose we need to do first? The 1/2, because that's a product, so we have to worry about multiplying before we do any adding or subtracting, okay? So what we're going to do then, everything with x is inverted, okay? So it looks like we're going to take half of the x value, but it's not it. We're actually going to do twice the x value. What did I do here to this fraction? Flipped it. All right? You have to flip your fraction and multiply your x coordinate. So I have a few points here. This is the point 1, 1. I'm going to write it above. 1, 1. And this point here is -1, 1. This point here is 0, 0. And in order to do this transformation, this is actually a horizontal stretch because we're going to take the x coordinate and multiply it by 2. So I'm looking at my x coordinate here. Multiply it by 2. What do you get? 2. The y stays the same. So it becomes 2, 1. The y value didn't change. We're only changing the x. Here is my original ordered pair at -1, 1. Multiply the x coordinate by 2. What do you get? -2, 1. So there's that point, -2, 1. 0, 0, 0 times 2 is still 0. So that stays. So here is our wide function that had what we call a horizontal stretch. Horizontal stretch. By a factor of 2, you can see how it pulled those x values wider, all right? So we got wider horizontally, stretched horizontally. All right, now we've got our wide graph there. What does this +1 do? Up 1. So I'm going to take my red points and just count up 1. Up 1, up 1. So we can do these graphs in steps. So here is our actual function in green. So you had a base graph, we have a horizontal stretch or shrink, or compress rather, and then a shift. The domain, how far left and how far right does our green graph go? Infinity. So -infinity to +infinity. What's our range? Good. Our lowest y value is 1, and it goes up forever. So 1 to infinity. Bracket 1 to infinity. Okay. Let's look at letter B. We have y equals the cube root of 2x minus 3. All right. What is our base graph that we're going to start with? The wave. Yeah, the base graph is the cube root of x, which is that wave function, or breaking wave. So I'm going to go ahead with my 3 main dots here. And my little base graph, which is just for reference for general shape here. So I'm making it dotted. So there's our base function. Now, how many transformations do you see? 2 transformations. We've got a 2 next to the x, and we have this minus 3 here. Which one do we need to do first? The 2x, yeah, because this is 2 times x. Now, but what do actually we have to do for this? 1/2. Whatever this number that is being multiplied to x, you have to flip it. So this is 2 over 1, and you flip it, what do we get? 1/2 times x. So that's what we're going to do. We're going to take our x coordinate and multiply it by 1/2. So again, if I'm looking at my ordered pair here at 1, 1, I'm going to take that x coordinate and take half of it. What's half of 1? 1/2. So that means it gets compressed. 1/2, 1. That y coordinate stayed the same. So it moved horizontally closer to the origin, okay? That's what's happening. This is a horizontal compression. I'm going to write that down, horizontal compression. So it's literally squeezing closer to the origin horizontally. Here we had our original point at -1, -1. So I'm going to look at that x coordinate. What's half of -1? -1/2. So the y stayed the same. So there's that point right there, -1/2, -1. 0, 0 stays where it's at. So this got smushed horizontally. So it sort of shrunk this way. Right. And then the very last thing we're going to worry about is this. What is this transformation doing to my graph? Down 3. Very good. So I'm going to take my red points now, my red points, and I'm going to count down 3. So down 1, down 2, down 3. Down 1, 2, 3. And down 1, 2, 3. Can I graph this one on my calculator? You can. Got to know how to do it. So I need you to practice so that you can do everything on your calculator come test day. This is a great grade booster test if you know how to use your calculator. Looking at the green graph, what's the domain? How far left and how far right does it go? Infinite. Forever to the left and forever to the right. What's the range? Yep, forever low and forever high. Do you guys have questions so far? Everything with x is flipped. Everything with x is flipped. That's what we have to remember. Yes, sir.
Will we have enough time to still do it if we know how to do this, but we don't have a graphic?
Oh, I think so. And if you need more time, then that's fine. That's fine. It's not an issue. And since it is a matching test, you can usually eliminate quite a few options. So, all right. We have y equals 1/3 x, quantity squared, plus 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I guess I'll make that a little taller. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, what is our base graph here? Basic shape? Parabola. This is x being squared. So this is y equals x squared, which is our parabola. So I'm going to plot those 3 main starter points, and I'm going to label them right now, since I can. -1, 1, 0, 0, and 1, 1. And there is our basic parabola shape. How many transformations do you see?
2.
two transformations. So we have the 1/3 and we have the 4. Oh, geez. Okay. And let's see. Which one do we need to do first? Yeah, the inside. Inside with x is a product, so we need to worry about multiplication before we do any adding or subtracting. So again, you have to flip your fraction. So that becomes 3 times the x coordinate. That's going to take your x values and make them 3 times larger. That's going to be a horizontal stretch because we're getting things larger values. So this graph is going to get pulled outward horizontally. So I want to look at my x coordinate. We were at 1, 1. What does that point transform into? 3, 1. Very good. So that becomes 3, 1. That x value changes. -1 turns into -3, 1. The x value changes. 0, 0 gets to stay where it's at, which is kind of nice for us. So we get a much wider parabola. And then we can do our last transformation. What does this +4 do? Up 4. And so I'm just going to take my points and count up 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And so there's our actual graph, is the green one. Again, we can check it on our calculator pretty easily, as long as you know how to work your calculator. 1/3 times x, quantity squared, plus 4. Oh, zoom 6. Looks pretty good. This is the point 0.04 on my graph, and you can use trace and type in 0, and it gives you the output of 4. I don't know if you can see that. Barely. There you go. So 0.4. And this would be the 0.35. So I could check 3 as well, and I get 3.5. So you can use trace to check those ordered pairs, just to verify that you've got it right. What's the domain of this function? Good. -infinity to +infinity. What about the range? How low does it go? 4 is my lowest y value, and it goes forever up. So bracket 4 to infinity. All right. I'm going to give you a second to make this picture. This is a generic graph. This is the graph y equals g of x. This is generic function that I just made up. On your test, 5 questions will be based on generic functions that you will not be able to use your calculator for. So you just have to know how to do them. All right, how many transformations do you see? 2 transformations. The first one, let's see, it looks like this is got a -1 times my function. And then we have a 3 times the x. What do you want to do? 3 times the x? Okay, so this is the number in front of x. So what do we have to do to that number with x? Flip it. Yeah, so that becomes what? 1/3 times our x value. That's going to cause a horizontal shrink. So we're going to take our x values and multiply them by 1/3. What is the other transformation that we have? Not everything. So this number -1 is multiplying. Okay, so we are going to multiply. Is it inside with x or is it on the outside of the function? Yeah, since it's outside, anything on the outside affects the y's. All right, so anything on the outside of a function affects the y values, which is what's happening here. The y value is changing. We became 3.5, so that y value added 4 to it. And so this is actually doing -1 times the y coordinate as well. That's going to cause a reflection. All right. And the nice thing about things with y is you don't have to change them up at all. All right. So we're going to do two things. We're going to multiply the x coordinate by a third, and we're going to multiply the y coordinates by a negative, and that's going to give us our new points, which is kind of nice. I'm going to go ahead and label these. This is the point -4, -2. This is the point -1, 2. This is the point 2, 2. And this last point is 3, 1. Maybe I'll make a list, because sometimes when there's lots of things happening, it's hard to see what happens. Where do I have space? I have space down here. I want to make a list. My original points were -4, -2, -1, 2, 2, 2, and 3, 1. And I'm doing two changes. I'm going to take the x coordinate and multiply it by 1/3. And I'm going to take my y coordinate and multiply it by -1. So I'm going to change all of these x values. So let's see. So what does -4 turn into? We're going to do, yeah, -4 times 1/3 would be -4 thirds. -4 thirds is 1 1/3. -1 1/3. -1 times 1/3. -1/3. Good. 2 times 1/3. 2/3, yeah. And 3 times 1/3. 1. So some interesting values. And now we're going to look at all the y coordinates, and we're going to multiply them by a negative. What's -2 times -1? 2, +2. 2 times -1. -2. 2 times -1. -2. And 1 times -1. -1. So all I have to do is plot these points, and we'll have taken care of all of our changes. So -4 thirds 2, -4 thirds is -1 1/3. And we're here at 2. We have -1/3. -1/3 is just a little bit to negative side, and then -2. 2/3, not quite to 1, and then -2. And then 1, -1 is right here. So this is our transformed function. So this is y equals -g of 3x. So you can see how it got flipped upside down, but then it also shrunk in. It compressed to a third of its original size. Okay. What is the domain of our green function? What is our furthest left x value? Yeah, -4 thirds right there. So -4 thirds and 1. Good. -4 thirds to 1. And what's our low and high value? -2 to +2. Very good. Our low value is -2. Our high value is +2. All right. Questions for me? All right. So sometimes lists help. You guys have class practice 26.